Hello everyone, welcome to session 2. In the previous section, we have talked about the overview of VxLAN with BGP EVPN control plane, how it works, and what are the different ways it can learn the MAC addresses from the remote switches. We also briefly talked about the advantages of VxLAN over the traditional spanning tree. We in this session we also talked briefly about the topology what you're going to use in the lab. Now in the coming sessions, we are going to deep dive into the lab. We are going to take a deeper look into how to build up a network with VxLAN, EVPN, BGP EVPN. We will take a look at the underlay first. We will make sure that unicast is working. We will configure the multicast. And once we verify everything is working fine in the underlay, we are going to move to VxLAN L2 VNI configuration. In the next session, we will take a look at the L3 VNI configuration as well, where we can route the packets between the VLANs. And finally, we will take a look at the route type 5 configuration, where we can make the VxLAN network talk to any of the IP network. And that will pretty much conclude our whole module here. So before we get into the CLI, let me bring up the topology once more, just to make sure you are familiar with it. So this is the topology of what we have. We have a VTEP1, where we have a client connected. It connects to a router in between, which is acting as my route reflector, BGP route reflector, which is going to reflect the EVPN routes from one VTEP to another VTEP. This is going to be all iBGP. Then we have VTEP2. So VTEP2 has client connected, which is both in VLAN 10 and VLAN 20. We have VTEP3 and VTEP4. VTEP3 has a client connected, which is which is in VLAN 20, and then VTEP4, a client is connected, which is external IP network. This is neither in VLAN 10 nor VLAN 20. So VTEP4 configuration, we are going to take a look at that later on, not right now. The first task for us would be within the box. We want to make sure that the VTEP1 can reach VTEP2, VTEP3, VTEP4, and the route reflector, of course, in the between. Then we will configure the multicast as well. We will configure this route reflector in between as a multicast rendezvous point. In a production network, you might want to have redundant route reflector. Redundant rendezvous point using the MSDP. But here you don't need that. In the lab environment, just for the example, I'm using only one. And once that part is done, then we will see how to configure the overlay. Now here and again, just to reiterate, the VTEP1, it is connected to only VLAN 10 client. It doesn't have any VLAN 20. And then on VTEP3, it doesn't have any VLAN 10. It has only the client in VLAN 20. But only the VTEP2, which has the clients both in VLAN 10 and VLAN 20. Okay, that's the final communication how it will be. So the end goal is to make sure we can ping from 192.160.10.11 to this 10.21. This will be the goal of L2 VNI configuration. Once we are done with the L3 VNI configuration, we want to make sure we can ping from 10.11 to 20.21 as well, and 20.31 as well, and then vice versa. Okay. All right, let's now get into the CLIs. So on the left side, the leftmost one, this is my client, what we talked about. It is in it has different interfaces configured in different VRFs, just to make sure I'm keeping it separate. And I have simulated this particular device as a client of different clients. It has different ports connected to all the different switches we have seen in between, and it is basically emulated as a client. Then we have the VTEP1, then we have the route reflector, we have VTEP2, VTEP3, and VTEP4. It is in the same order as you have seen in the topology. Now, the first thing, show run interface loopback 0. I want to make sure that my VTEPs, they can talk to each other to the loopback. I have configured the OSPF already. There is nothing fancy in that. That's the reason I didn't want to show it to you. You can see that under the loopback, I have OSPF configured. Also in the physical interface, which is connecting my VTEP 1 to the router reflector and the other connections. We have physical connection and the logical layer 3 connections. I have configured OSPF on those interfaces. And finally, if we do a show run section router OSPF, you can see I have configured router OSPF and defined router ID. It's a pretty vanilla configuration, nothing fancy here. And we have the same configuration on all these 4 routers. If you go to router 4, if you do a show run interface to gig 102, this is the interface which is a network interface connecting the core, facing the core. And if you do a show run section router OSPF, if you do a show run interface loopback 0, you can see that I have configured OSPF here. The same thing here. On router 3, if I do a show run section router OSPF, show run interface loopback 0, the same configuration you can see on pretty much all the devices here in between. Now, if my OSPF is working, I should be able to ping across them. The loopback of the VTEP 1 is 10.0.0.1, the loopback of VTEP 2 is 10.0.0.2, and so on. So the loopback of VTEP 4 is 10.0.0.4. Let me try to ping that with the source of my loopback. It is working. Let's test it for the VTEP 3, VTEP 2, and also for the route reflector, which is 10.0.0.9 in between. Okay. At this time, since my unicast basic connectivity is working fine, the next step for me would be to configure the multicast. For multicast, as I talked about, we will make the route reflector in between as a multicast rendezvous point. So pretty much all I need to do on the other routers is, first I'll go to config T on all the routers and I'll configure IP multicast routing. After that, I'll go to interface. Also under the loopback 0, I need to configure that because I'm using the loopback as a source and I need to configure IP PIM sparse mode here. Okay. And then I will go to the respective interfaces, which is core facing interface, and I will configure the IP PIM sparse mode on this guy. It would be port channel 1 to port channel 2. If you look at the topology, this VTEP 2 has 2 interfaces. Sorry, it has no port channel 1. Port channel 2 is what I need to configure this on. Port channel 2, IP PIM sparse mode. And then 2 gig 105 and 2 gig 106. We'll go to VTEP 3. In VTEP 3 on VTEP 4, only 22 gig 102. On the router in between, which is route reflector, on both port channel 1 and port channel 2, I need to configure this. Additionally, since I want to make it a route rendezvous point, I need to configure the RP candidate. I'm using the BSR. So that my tunnel can be configured dynamically. Now let me run this command, show IP PIM RP mapping on all the routers. And let's make sure that they all know about the rendezvous point now, because this is important. Without that, multicast is not going to work. This is 10.0.0.9, VTEP 1, VTEP 2, 10.0.0.9, VTEP 3, 10.0.0.9, VTEP 4, 10.0.0.9. So you can see that all of them, they can see the route reflector router as a rendezvous point as well. So we can pretty much confirm that multicast basic configuration is done. Now, at this point of time, I think we are good enough to start building the VxLAN overlay configuration that we need. Let's take a quick look at the topology once more. Here, you have 101 interface on VTEP 1. Let's focus on VTEP 1 first. We will configure the required things here. And after that, we will copy the configuration, we'll make the changes, and we will put it on other VTEP switches. All we need to do is we need to first, of course, this port is definitely under a VLAN interface, VLAN 10. We will need to create a L2 VPN EVPN instance for VLAN 10. We will need to configure the route targets, because as you are going to exchange routes through the EVPN, you need to make sure that you have the right route targets configured, which you can use to import the routes. This is pretty similar to your VPN IPVRF configuration. You have the route target configured, and then you import the route target from the VPN-before address family based on the route target you have. Very similar concept here. This is L2. We are talking about L2 VNI. We don't have any IPVRF, but we have L2 EVPN instance, and under that we will configure the route targets to achieve the similar kind of functionality. And after that, we will map the VLAN number, the actual VLAN number 10, with the VNI, what we talked about in the first session. And then finally, we will configure the overlay. So let's take a look at that in action. What we have here in this port, this is actually port number 1. Okay, this is port number 1. You can see that this is connected to my switch. This is basically emulated as a client. If you do a show MAC address table interface geek 101, you can see that I'm just learning the one MAC address in VLAN 10. I need to go to L2 VPN EVPN. I need to define the router ID. I'm going to do the loopback 0. And the replication type is going to be static. That's the only option I have. Ingress I cannot do actually. I mean, ingress is something what you do when you want to do head-end replication, but that's something we will not do here. I will replication type static. We want to map the replication multicast group. We will going to bind that multicast group to one specific VNI. We will look into that when we do the overlay configuration. Then we will configure the EVPN instance. This is instance number 10. Encapsulation is going to be VxLAN. Then you define the route targets, both import and export. This route target, it has to match on all the VTEPs where you want to configure or where you want to extend this broadcast domain to, right? You can give any name. So this is for VLAN 10. So let me give a name 10 : and then the VNI number. Let me choose the number 100010. No auto route target. The route distinguisher I'm not defining because it can be selected or it can be determined by the system itself automatically. So I'm going to skip it. Then we will go to VLAN configuration 10, and then we need to map this VNI number to this VLAN. So we'll do a member EVPN instance 10 and VNI 100010. This is my VNI number. This is how I'm mapping it manually. So VLAN 10 is now the VNI 10010. So whenever my VTEP 1 is going to send the packet to VTEP 2 for this particular client in VLAN 10, it is going to strip off VLAN 10 and it's going to put the VNI number 100010. Then on the remote side, whenever it receives it, it knows that if it needs to be processed in VLAN 10, it will do the reverse mapping. And that's what we are configuring manually here. So quite a bit of manual configuration you need to put here. So now that my EVPN instance is built and my VLAN configuration is built as well, I'll go to interface NV1. This is going to be my overlay interface like we do for tunnel 0 for GRE or maybe for DMVPN, and interface overlay 1 for OTV. Here interface NV1, which is network virtualization edge. You do a source interface loopback 0. This is the VTEP source ID. Okay. The host reachability protocol is BGP. We are going to build the control plane based on the BGP EVPN. We need to map the member here the member VNI 100010, hit enter, and then you need to define the multicast group, what we talked about, the replication type. If the VTEP1 needs to send a broadcast packet to the network over the IP, then it will basically send it to a multicast group, and then whoever is tuned to that group, they will receive the traffic. And that's the reason your multicast was needed to be working in the underlay. So 239.0.0.10, I'm choosing any IP address I want, and then finally doing a no-shot. We will review the configuration, what we are doing. Before that, let me go to router BGP. I already have some basic configuration built. You can see that I have configured router BGP 10. I have defined the neighbor 10.0.0.9. I'm only defining it the route reflector neighbor here. I do not need to configure full mesh. What I will do now is router BGP 10. I need to create a new address family, which is L2 VPN EVPN. So if you have done VPLS, you know that you can configure L2 VPN VPLS. But here we are going to do EVPN. We need to activate the neighbor, which is the route reflector in my case. And also we will do a send community both, because all these route targets, what you're talking about, the labels for the VNI, this all will be mapped to your, will be sent over as an extended community. So we have to make sure we do send community both. And now if you look at the entire configuration, what we have done, show L2 VPN and VLAN configuration plus router BGP and NV1. Let me copy this configuration and let me put it in a notepad. So if you now look at this, this is all I have. I have first configured the L2 VPN EVPN. I have defined the replication type and the router ID. Then I have configured L2 VPN instance specifically for VLAN 10. If I had multiple VLANs, I needed to configure the same thing for multiple instances. We will do that when we do it on VTEP2, because VTEP2 has both VLAN 10 and VLAN 20. Then I am going to map my VLAN number with the VNI number. After that, I configured the overlay interface. I defined the source interface as loopback 0. The host reachability protocol is my BGP EVPN. And then I'm going to bind the member VNI with this multicast group. The reason I need to define the multicast group is, even though EVPN is going to advertise all the layer 2 information proactively, but still if my host needs to send a broadcast packet, let's say ARP, then you will need to forward the packet to a group, right? Or if there is any silent host, you will need to forward the packet to the multicast group. Then under the router BGP 10, this part is already configured, so I'm not doing this. Let me still keep it here. Then address family L2 VPN EVPN, this is the only thing I'm adding. I'm going to activate the member 10.0.0.9, which is the route reflector IP address, and then the send community extended. So let me write the configuration here on P1. On the P2, on the VTEP2, if you look at this topology, on the VTEP2, since we have both the clients, VLAN 10 and VLAN 20, I need to do the same thing, but additionally for VLAN 20 as well. Let me try to edit it out here. So for router 2, what I will do, I will keep this configuration same. It is not going to be different. Since it also has a VLAN 20 locally present, I will configure the instance for VLAN number 20. I will give a different route target name, just to make sure I understand what is what. For like what we mapped for VLAN 10, we need to map the VNI number for VLAN 20 as well. The interface NV1, I need to configure the mapping for VNI 20 also. You can use the same multicast group, but you don't want to keep the flooding domain same for all the VLANs, right? So better to use another multicast group here. Under the router BGP, the configuration is not going to be the same, different, because you are just configuring it for route reflector. The router ID would be now 10.0.0.2 because I'm going to configure this on VTEP 2. So that's the configuration of the EVPN globally, then the instance number for VLAN 10, VLAN 20, then map it for both VLAN 10 and VLAN 20. Then you configure the overlay where you map the configuration. And then in the BGP where you configure the route reflector and you define the address family for EVPN. Let me copy and let me paste the configuration into VTEP number 2. Now, if you go to VTEP number 3, if you look at the topology, I have only VLAN 20. I don't need to have VLAN 10 there. So what I will do is I don't need VLAN 10. I will remove this. For VLAN 20, this is all I need. Sorry. I do not need VLAN 20. So you can see that quite a few repetition of the configuration. If you have it built for one VTEP, you can easily edit and you can modify the other VTEP configuration. It will be 10.0.0.3. I'm not going to do anything on VTEP 4 as I talked about. We will take a look at that after we are done with the L2 VNI configuration. So as of now, that's pretty much all you need to do for VTEP number 3, which is only VLAN number 20. I'll go to VTEP 3. I'll put it here. Now we need to make sure we configure this on the router 2 as route reflector as well. I already pre-configured that. Let me show you the configuration I have here. There is no VxLAN specific configuration on the route reflector, just simple BGP and the routing and the multicast. You can see I have defined a template for iBGP policy. I configured that as a route reflector client, send community extended. And then I have defined all the neighbors 10.1, VTEP 1, VTEP 2, VTEP 3, and VTEP 4. And then I just defined them in the L2 VPN address family. That's it. Now, if you go to the VTEP routers, if you do a show BGP L2 VPN EVPN summary, you can see that I have one neighbor up, which is the route reflector. Let's go to VTEP 2, VTEP 3, VTEP 4. VTEP 4 I have not configured, sorry. So VTEP 1, 2, and 3, you can see your EVPN address family is now built. If you do a show NV peer, you can see your NV interface is up. If you do a show NV, and then if you give the VNI number 100010 and detail, it says that it is up in the layer 2. The layer 2, it says IPv4 is down because I'm not doing any L2 VNI configuration right now, but this is my local VNI information. Okay, it says about the packet counters. If you do show the same command, show NV100 detail on VTEP number 2, you can do the same thing for 20 as well, because here you have defined both 10 and 20. So now at this point of time, if you want to ping from this client 10.11 to 10.21, which is behind VTEP 1 and VTEP 2, let's see how it is working. So if I go to this this client here, show IP ARP 192.168.10.21, there is nothing. Let me try to ping now 192.168.10.21, and it is working. If I do a show IP ARP, this is the MAC address of my interface, which is for 10.21. If we go here and do a show BGP L2 VPN EVPN, you can see that this is my route distinguisher table, which is 10.0.0.1 my IP address .10. And you can see I have learned two host routes. One is 10.11, which is connected to me directly. And you can see that it has nothing mentioned here, which means this is my own, I'm the own router who own that. This is my weight, because in BGP you follow always locally originated route, you put a weight of 32768. That's what you have done here. But if you look at 10.21, which is a remote route, You are learning it from the VTEP number 10002. That is the reason it is important to make sure you have connectivity between the VTEPs, because now when the when this VTEP1 is going to route the packet for this destination and this MAC address, it is going to encapsulate the packet with the destination IP of 10002. So if you don't have reachability there, it's going to break. Similarly, if you run the same command on all these routers here, you go to router number 2, you can see that on the router number 2 also, VTEP2 also, for this 10002, it has learned 21 and 10.11. Now, if I go to this client here, 10.20.21, let me see if I can reach 20.31, which is over site number 3. Or maybe let me go to site number 3 and let me try to reach 10.20.21, which is in site number 2. As you can see that I have configured all the basically clients are on the same switch, but it is all in the different VRFs. So 20.31, if I do show run interface gig 106, if I try to ping from this VRF to 192.168.20.21, which is behind another VTEP, this is working. So at this point of time, we can confirm that the L2 reachability is there between all the VTEPs. Between all the clients here, 10.11, it can reach 10.21, and then 20.21, it can reach 20.31. However, if you now try to reach ping 192.168.20.21, which is in another VNI, you cannot reach that. So for that, we will need to configure the L3 VNI, and then we will take a look at the configuration in the next session. Thank you for watching. We'll come back soon.